Welcome to the Continuous Delivery Podcast. My name is Zarar. A special guest joins us today here, Ian Gartley, who have worked with before, former Meta employee. I know I only say that, Ian, because on LinkedIn, I see a lot of people putting like ex Meta, ex Amazon. And I'm just wondering, are you a ex Meta guy on LinkedIn? Do you put that on there?
I don't put it on there explicitly. Like I guess I don't know if that's like a value add, because especially lately after layoffs, you're like, did he leave voluntarily? You know.
And some people take it a little too far. I feel like they start putting like ex Shopify. I feel like that's not at the same category as the FANG companies, if you will. You know,
I could put ex RBC. You know, I don't know if that will help.
I don't think it will. They just hired too many people for it to be meaningful.
Yeah, to be an exclusive sign of talent.
Yeah. I don't particularly read too much into it because, as you said, you have no idea why they left, and it's kind of weird. It's kind of show offy too a little bit. Yeah. I feel, you know.
I don't know. I guess the other way of finding out if candidates are good. I mean, I go like interviews. There's still no good way really to find out candidates are good. The FANG company is like, do you have the endurance to like grind through our interview process and the prep you need to do? And if the answer is yes, then maybe you're a FANG candidate. That to me seems to be the recipe.
Let's start there. You and I worked together at RBC for a while, and that's where we got to know each other. And since then, we've kept in touch. And you're somebody who's always been a kind of like somebody who I've always respected in terms of like technical skill and vision and so on. So I thought I'd have you on and we talk about a few things. And we got a couple of topics lined up. But let me start with what we just finished talking about, actually, is the interview process, right? And I think you and I have chatted about briefly on what kind of questions would you ask a developer or an engineer when you are trying to hire them. Now, let me set this up for you. Say they've passed the HR, they've gone through they've checked out their history or whatever. You're hiring for a senior programmer position. Well, let me make it more challenging. Intermediate developer position. You're hiring for an intermediate developer position. You are, Ian Gartley, are the final round before you make the decision on whether to hire this intermediate developer. Walk me through, and you've done a lot of interviews, walk me through what you ask people in that situation to kind of gauge whether they're ready for an intermediate developer and soon to be hopefully a senior developer.
Honestly, I've been thinking about this lately because I actually don't think my latest question is giving me good signal to noise. And I think maybe the one other advantage FANG has is they're probably way more rigorous about tracking questions and like maybe post. I don't know. I assume that they can look at like post interview performance and maybe like, hey, this person passed this question and was terrible, and then eventually you have enough of those people, you can be like, okay, this is not a good question to ask. Lately, I've been doing system design questions. And it's also very hard. I think it's very hard to figure out on a system design. Like, people will get the basics of like, hey, they can draw like 5 boxes of like, I'll put an Angular app or a React app or whatever connected to API server, connected to database. And then like, I'll do like data streaming to blah or whatever. And you're like, okay, cool. But it still doesn't tell me like, I feel like there's probably another category of design question that's probably out there that I should start asking. Anyway, back to your original question, what do I ask for an intermediate developer? I'd probably do a code question. And I'm trying to think of, I haven't done one recently, so I'm trying to think of what code question I'd like to do, but it also depends on your company. Like FANG like goes to the algorithm, and I guess for a lot of people, like a lot of day-to-day is an algorithm. So like, what do you want to actually screen for? Like, maybe it's actually like, how good are they at just writing like, testable code? And maybe I think that's probably where I'd go with an interview question is like, give them actually a little bit of code and say like, write some tests for me and see how they respond to that.
Yeah, I know. I find that I like to observe how they start approaching a problem. Like the starting point they take when they are trying to solve a problem. Like even if you go like, hey, you're developing the next Uber, how would you design you're responsible for making the next Uber app, obviously not the real Uber app, but something like simplified, right? And as you said, a lot of people will kind of jump into like, I'll have the kind of like the N-tier architecture and they'll start there. But I think the better question to ask for somebody who you're kind of grooming to be a senior developer or a senior engineer is to whittle down the requirements so that you have to develop less and your architecture is less complex, because you automatically sort of assume that I need these 4 or 5 different boxes. And I think when people start first questioning whether you need the box is a sign that they have sort of like lean thinking, MVP thinking, because honestly, like a lot of these apps, a lot of these questions, you could take the same architecture and kind of copy paste it and remove like 4 or 5 boxes, and that's the answer. But I find the starting point is sort of important, because at the end of the day, you don't want to end up in a situation where your architecture is overly complex or you have too many boxes. So I find that if you're able to get somebody who draws the least amount of boxes, kind of your MVP of boxes, I think you're on the right track. What do you think?
Here's my struggle. So I have a question. I'm not going to tell you what the question is but I'll tell you, like, conceptually, the question ends up in a spot where you store way less data than you need, or like the problem sounds like it's a big data problem, and then it turns out like you could store the entire app's data requirements in like a couple of gigabytes or something like this. And when people do the calculation, they're like, oh, that's actually not that much data. But people still end up just saying, well, throw it in a data. Like, there's nothing that they do with that information to like make the app better. Or I haven't seen somebody yet being like, well, no, I'm not going to build this complicated thing because the data requirements is like a couple of gigs. So like you could literally load it into memory if you wanted. Or just like stick it in a flat file. But to date, everybody still goes with like the traditional thing. And then so I'm still left with the problem of like, well, of these candidates who've proposed like, the traditional architecture of like, service putting into database, what do I do with that? And that's where I struggle, where I'm like, I don't know. And then there's a couple of people that are like, after they start coding at the company, you're like, man, their architecture seemed all right. How did they end up being such a bad coder?
Yeah, because I'll tell you why. Because if you are preparing for a technical interview with any company, what you're going to do is you're going to go on YouTube and you're going to look at how do people interview for these things. And I've gone through it. And I can tell you, like, most of those interview prep questions kind of follow the same method. Yes. They really are just boilerplate. Of the 1,000 videos that are out there for let's say interview prep, I'd say they fall into like 4 distinct categories, and they're pretty much homogenous in terms of. So people look at that and kind of apply that to the interview. Again, what I find missing is sort of the MVP thinking in those. So that's kind of like where I am with that.
My guilty secret is I built like a Lucid chart template for the system design interview, basically outlining that process. So whenever I'm doing the interview, if I'm interviewing somewhere, I'll just like pull up this template and being like, okay, here are the 6 things I need to do, starting off with like, requirements gathering and pruning, and then like draw my boxes, and then, discuss the pros and cons of the choice. So it's like, I think you can really prep well for that interview. So that way, you're not spending your time like, drawing boxes and that sort of like I even have like, like the data, like all the icons basically like structured in this chart where I can basically like, copy this piece and just plop it in. People generally tend to like the preparation I found too for this interview where if you come prepared, like with your own chart, people will like that.
Yeah. Well, I think that's about interviews. I think I'm still learning how to, on either end of the interview, how to perform. But I think one sort of lesson I have, one learning that I have of this whole process is that I think if you start with the customer problem and work your way backwards, instead of starting with the architecture diagram and then justifying it, is probably the way to go. Because 100%.
And maybe the last thing, like you as an interviewer, and I should do a better job of this, is record not like physically video record every interview, but if you document every single interview you've been in and the questions you've asked and the outcomes of that, like if you spend the extra like 5 minutes at the end of every interview, basically creating your own personal database of like, here are all my interview experiences, I think you'll become better as an interviewer because you can go look back and you don't have like the collective sample size, but still, over your course of career, if you do, 50 or 100 interviews, it's still good to go back, I guess is the other thing I've learned.
A good old retrospective.
Yeah.
Okay, let's move on to our next topic. We also were talking about, so lately I've been into Elixir a lot. I've adopted Elixir for Jump Comedy, which is my startup, and I've been using the sort of, I was working on a Node application pretty much the entire time. And then I was like, I'm kind of getting bored of Node. First of all, it's kind of a bit of a memory hog sometimes. I keep trying to increase my Node max memory size to like 8 GB, just so this one operation runs cleanly. So I decided, okay, why don't I just develop another application against the same database and just offload some of the transactions and offload some of the work basically to an Elixir app. And
wait, are two services talking to the same schema? Are you doing the verboten, thou shalt not do this architecture? That's
so this is the great part, right? So I'm doing this and I'm like, this feels wrong because I've been told this is the wrong thing to do.
But it's so nice.
You get to experiment more, you get faster, you learn more. And then I started Googling this up and I came across this Substack post, which was talking about different architectural patterns. And this one guy was talking about the sidecar pattern. Okay. And then I looked into the sidecar pattern a little bit more, and I'm like, what I'm doing is the sidecar pattern. This is exactly the sidecar pattern, and it's getting more and more momentum. And then I think the reason that I wanted to talk about microservices a little bit more, even though that horse has sort of been flogged to death at this point, is that I feel the sidecar pattern is what most microservices end up as. So why are we even pretending to do microservices when really what we're doing is developing another app or service talking to mostly the same schema? So I feel like the sidecar and microservices are getting a little, they're getting blended in a little bit. And I personally have found the sidecar experience to be a lot better, a lot cleaner. Yes, I do break the kind of the golden rule that thou shall have data isolation in your microservices. But honestly, man, I've seen a lot of microservices, and there's not much data isolation across them. What have you come across in the wild? Where do you sit on this? Let's call it sidecar versus microservices patterns.
Maybe I won't engage necessarily in the sidecar thing, but I think maybe initially is, I'm guessing most companies, their data model is actually monolithic in some ways. So why don't we start with the premise that when you're building an app, that performs some function, to enable fast development, you sort of actually need to know about all your entities, your like fundamental things. So I think there's this idea that was pushed for a many number of years that you can sort of decompose, your data model into these distinct, separate things. But I think probably in practice and in reality, for most people, it's like near impossible. Or yeah, you can maybe pick some boundaries, but also there's a convenience of like if your data model is all together in the same place, the time you actually need that other piece of data, like, it's just easy to access, and you can still use your lower level, within a service primitives to solve these problems. And so I feel like Sidecar is sort of in that thing, like you're defining a single data model for your problem space. You've built up multiple things that you need to do. One of it happens just being a different language. For you, it's this, one person working on this, it's fine. You can manage schema across these two things and not screw it up. I'd say that like my other thoughts, like on this like rule, thou shalt not, have two applications sharing the same data model, is probably, like if you're in a heavily siloed company, maybe that's a really good rule to follow. But if all your developers can see the entire code base, then if you're updating your schema, if you have a global schema update, maybe it doesn't matter as much. And anyway, okay, maybe I'll pause there and let you like jump in on some of these. Like without we could probably start saying stronger things about microservices in a few minutes, but maybe that's a good.
Yeah. So I love it because I get to experiment with different toolkits and languages, which I think is key to innovation. I think without experimentation, you don't really have innovation. And I think oftentimes you talk about experimentation from a product point of view, like try different features and so on. But I think technical experimentation is equally, if not more valuable. And I'm telling you, just based on my experience over the last 4 months, like I've written a sidecar in Go, in Node, in Elixir, and in Java. And all four, I had a bake-off, and Elixir won hands down. And the big negative that I found that I find when I did this was the management of the migration schemas. So where if your Node app is making a change to your monolith database and your Elixir app is making also changes, well, now you're running into a situation where you may have dependencies in the order of which the migrations are being run. So I came up with a rule which says my Node migrations will run first, and my Elixir migrations or my Ecto migrations will run second. So that's the rule that I impose. So I'll never create a table in Elixir which then will be modified in Node, but I will go the other way around. So that's sort of like one kind of rule I had to put in to avoid that. But other than that, it's been pretty easy. I'd also say the one of the reasons that I did this is because I found myself, and we're trying to get into our third topic here a little bit, and we'll talk about microservices more, is that I just found that in functional programming languages, I'm just encouraged to write more tests. I feel that there's a natural, the setup costs of writing tests in functional languages is much lower than the setup costs of writing in against classes, just because of the constructor injection and all that. And I think I only discovered that because I experimented with 4 different things. If that means I broke some sort of weird microservices rule, so be it. We'll come back to the functional testing. But let's get back to microservices. I have the only good microservices implementations I've ever seen are ones that are so isolated that they have a very small data footprint and do one thing very cleanly. For example, I have one microservice, which all it does, it's an image microservice, which goes and takes a screenshot of a web page and returns the PNG.
Right.
That's the microservice.
And it's probably tangential to your actual data model.
Yes.
Or your core application model.
Yes. And I'll say one more thing on that is that I find it beneficial to have microservices when I know that my scaling needs are very specific to that microservice. When I know that this is going to be a choke point at some point, and I need to scale this, maybe add like 4 or 5 VMs during peak load or whatever. And at that point, it becomes a money-saving mechanism, because instead of scaling your whole monolith or your entire app, you're just scaling a small portion of it. But other than that, I honestly, and I've seen a bunch of smart people, smarter than me, talk about this, and they're sort of arriving at the same conclusion, that just because it sounds like a utopian, nice idea doesn't always mean it is.
Yeah, I think it's more often than not, it isn't. Especially, there's like absurdity. Like, I'm working at a company where there's more microservices than there are developers, and you're like, how is this possible, right? Like there's some basic, like, to the point of like, well, do all these 250 or 300 microservices have bespoke scaling needs that they couldn't really be in one code base? And the answer is probably not. They're all like, they all are either like a request response like API provider, or the other one is there's sort of like, I think, 3 main patterns. I think you can probably build most apps today. So obviously request response, hey, users interacting with your app. The other one's sort of event processing, like a data stream that you're processing, inputs, and for each message you got to do something. The third one's probably a batch job. And if you maybe step back from microservices and build an architecture where you can scale a request response independently from your async from your batch, you're probably going to be in a better spot, especially if you can share your data model. There's so many conversations that I think happen at companies where it's just sort of like, how much time is wasted talking about like, well, where should I put this piece of functionality? Like, no, it belongs in my service. And then the other devs are like, no, that belongs in this service Y. And then like, well, then you need to expose like A, B, C on your API. And like all that like melts away when you don't have these like artificial quote unquote microservice boundaries. And especially because, app B will need data from app A anyway. And so if you had the shared data model and built out your system differently, I think you end up in a better spot. I think mostly like Meta has done that. Like, I think it's probably they're the most, I'd say like, efficient in terms of, I've seen at least from like number of engineers to build like from bits on UI all the way to bits on disk at scale. Like, I think they're probably close to the most efficient I've seen, where it's basically one engineer to build, one engineer to approve, and that's partly like they have the mono repo quote unquote, but it's more really, I think it's about the data model, where like me as an engineer have access to this like global data model, and I'm not really spending time thinking about like where does this piece of functionality lie. It's more about what is the correct data model I need to build for this new problem space.
Yeah, and I think just data has become so disparate, like it's spread out across so many different things, that to try to isolate it to a particular service becomes problematic very, very quickly.
Usually.
And it's like sometimes, for example, I'm just speaking from my personal experience, or recent experience, I should say. Everything's from personal experience. Is that I have one big data model, but within it there are different concerns. So, for example, I have email campaigns, I have events, and I have, let's say, ad campaigns. All 3 sort of need to talk to each other, and there needs to be a join between those tables at some point.
Yes.
Right. And I just simply refuse to have a orchestration service at the top managing that. Yeah. I'm not going to reinvent the wheel when somebody has already invented how to do a left join. I'm not going to be very good at implementing a left join in any language. I think it's going to be buggy. It's going to be slow. I'm going to add another point of failure. So it's sort of a trade-off that I have made, that I don't want to write orchestration layers. I hate them.
Yes. Yeah. I agree with you on
I've
that
never
one.
seen a good one. I mean, there's a reason ESBs, the glory days of ESBs were so, I'd say, relatively short-lived.
Have you used Apollo GraphQL?
Yes.
Yeah. What are your thoughts talking about, orchestration layers?
Yeah.
Have you used their subgraph joining and that sort of stuff?
I haven't used it to that complicated of a level, but I am generally a fan of GraphQL for sure. I think the complexities of GraphQL lie on the implementation side, not on the client side, because it's very, very easy to write really unperformant or non-performant GraphQL backends. Because from a client perspective, I just give me the user's department store, users' orders. And for those orders, give me the products. For those products, give me the variants. For those variants, give me the sizes, right? From a client perspective, I love it. I want nothing more than that. But from a back-end implementation point, you quickly run into situations where you will end up compromising performance because of various different reasons. So I think you have to be smart about, if your GraphQL is just adding another relation to your join, that's not really GraphQL, right? You got to be smarter than that, I feel. So I love it from a client side. From a server side, I think I often have a little bit of a difficulty making performant applications quickly.
I've also, I think it makes sense also in Meta's case, where it was also a giant monolith, where their GraphQL exposes their graph database in some ways, right? And I hope other Meta people don't watch me, because they'll probably I don't know if I'll get pilloried for inaccuracies. But the other thing, so if you played around with Apollo, they have this thing which is like subgraph stitching, where it's like quote unquote a microservice architecture, where I could define part of the subgraph and you could define part of the subgraph, and I find it ends up being a distributed monolith in GraphQL world, and there's all these special Apollo rules that you need to follow to distribute your query properly and make it efficient. So I found conceptually GraphQL as a query language seems nice, but implementation, that it just seems like it ends up being that very bloated middleware that's orchestrating, trying to orchestrate. And at which point I'm like, okay, well, actually, and here's my argument. I don't even actually care. I don't want a query language from a client side. I think I want a client library. So that's my other thing I float out, maybe challenging the GraphQL supremacy of front-end clients, which is, I think people, what you really want is some replicated version of your data model in the client, and you to have an easy way to do that.
I'm all for. I've been using a couple of open source projects. One of them is called Medusa. It's like an e-commerce library. I use it for my app, and it's open source. Check it out, Medusa.js. The guys there maintain it brilliantly, and it's an amazing piece of software. And I do find that they expose the relations in the database to the client side. And at first, it felt kind of dirty. It felt I was breaking some sort of encapsulation rule, because remember, I went to school learning Java, right? When I went to university, I was drilled Java and object-oriented programming and encapsulation and all those things. So in a Java world, that's you're sinning there. Confess. You just expose your join tables on the client side. You can't do that. But the more I worked with it, I asked myself, I was like, what am I losing? I don't see a negative in knowing that the product table is joined with a product variant, and that's joined with something else, so on, so forth. I don't necessarily see it as a security risk, as long as the other things.
How do they join it? What do they do to expose this on the client?
So, for example, if you're making a call to the products endpoint, and you want to return, let's say, the variants that belong to the products and let's say a variant has a relationship with prices. Prices have a relationship with currencies, so on. You can actually specify in your query string the relations you want to expand on. So you can say /store/products question mark and pass in the relations you want to load. So products.variants, products.variants.prices, and so on. So the more you specify, the deeper the left join happens, and you get the result set back. And that's not because usually you would probably have separate endpoints for those. And but I like the fact that it's just one endpoint and I get to pass in things. It's like a poor person's GraphQL. I like it.
There is definitely, I guess like there is something nice when you're building something for other engineers where GraphQL could be quite nice because you don't really know all the things that they need for their use case.
Yeah.
Within a company, you sort of know that though. So I feel like the value is a little different. Mm-hmm. Where like, if I'm building my client and my server, and let's live in the world where you theoretically like can update your client, on demand. And maybe, like you've built it so you're not coupled to like the App Store release. Do you even care about what that protocol is for communicating data from client to server?
If you know what you want, yes. But again, let's go back to Agile and back to interview questions, because I think like one of my favorite sort of sayings in the Agile world is you defer all decisions to the latest responsible moment. You don't make a decision too early and take things off the table. It's like Bayesian logic, something like that. So that's why I think that's a great point you made there. If you know exactly what you want, sure, go ahead. But oftentimes you don't necessarily know exactly what you want. So in those cases, it's good to have this flexibility where the client demands what they want instead of working off a set of discrete APIs. Then over time, if obviously you decide that this is what I need, then you can always refactor. But I think if this was an interview question and you had to ask somebody to design this exact thing, maybe one thing you can probe for, and I like how we're tying this back, is that
to your interview,
to the interview question, is that if you had to design an API where you don't necessarily know what you want, how would you do it? And one possible answer might be, well, you pass in the relations because you don't know what you want, and you'll know later. What do you think?
Yeah, I mean, maybe that's one answer. I guess I float out the other answer too, is like, as long as you can change both sides quickly.
Yeah.
Maybe to me that's like the higher value, like on this value chain. Like, okay, yes, if I have like a developer working on client and a separate developer working on server, and they have to agree on a contract, then yes, at some point making the contract flexible is better than not, especially if they're working independently.
Yeah.
But if you sort of go on the other extreme and saying, actually, I want the one engineer to touch UI, to touch the data, like both sides of this thing, and then like this interface piece, like at some point, the only thing I care about is it easy to change, so that way this developer can make changes on both sides quickly. Then you even get out of this, like I float out like server side render almost, right? Like there's the other extreme of like, well, like what if you just like sent the view essentially to the client, right? And the client just is like this dumb renderer, and then you're out of this game of like, well, what's my data interface? Well, you don't need one. You basically, like, maybe on the server side you can think about like, internally the structure of your code, and like maybe the thing that renders view shouldn't be like writing, doing the database query, and that you want like a service or something in between to encapsulate business logic. But you don't really like, there's no argument there about what the protocol for transmitting data to client is. It's just, like generating HTML at that point, or generating whatever server side.
I feel we've come full circle. Let's dive into that topic a little bit, right?
Okay,
let's get into the server side rendering, because I started programming in 1996, maybe 1987, I say, and I think we've now come full circle from 2004, where we used to be completely server-side apps, right? I mean, used to render the HTML velocity templates. Some of the old Java people might remember that. I'm sure there were other ones too. WebWork, struts too. From those days, we have now come full circle. It's just called Next.js, right?
Yes.
Now we have server-side rendering. And now our stack is more complicated because we have a service, and then we have Next.js or Svelte or whatever. Just pick one, right? Which are making calls to your API, rendering the page and serving that. Instead of the server serving it, now you have it being served on the edge by another server, but behind the scenes, it's just server-side rendering. So if I had to make a prediction, I'd say the future might be going more towards having basically a monolith which serves both the HTML view rather than just the API which the client consumes. And I'm already seeing that with Elixir and Phoenix. I think they've gotten really smart about transmitting just the parts that changed over a WebSocket. And at first I was a little cynical. I was like, does it really work that well? Turns out it does. Turns out they're on let me just check right now. Live view version for Phoenix it's still at 0.2014. So it's not even 1.0 yet, and it's pretty good. So if I just kind of extrapolate the current behavior of how things are going, I would say we're sort of going back towards server-side rendering completely on the server side and going away from these frameworks. I don't know, kind of rambling there, but your thoughts on how that's going?
Yeah, I don't know. Possibly, and I'm possibly in that camp too, where it's like the last decade and a bit, where we're sold a bill of goods on how microservices are great and how client-side rendering is great, and it turns out what's maybe those early 2000 Java frameworks were awful in their own, server-side render frameworks were awful in their own ways, but what we really want is a developer productivity and developer efficiency. And we've sort of ended up in a spot where, okay, you got to go understand how to do React, and it's or these front end patterns to render on client side that are, inherently complicated. Build out an API, which is then, the transmission model is inherently complicated. You end up with a fat orchestrator and quote unquote a bunch of microservices, and then that's how many engineers does it take to screw in a light bulb? You get to this point where it's 15. You're like, well, why do I need 15 engineers? I need one iOS engineer to write the code, one to approve, and then Android, and then web, and you're up to 6. Then you're like, oh, I need a person working on the orchestrator, add 2 more engineers in there, 8. And then, well, you got 5 different microservices just to render this page, and they each have different developers, so you throw in another N developers there, and you're like, all this was to add a freaking button to a UI, and you're like, this is where it's I think the enemy is complexity here, and maybe both of those worlds have complexity, but there's a simplicity in server-side render. If you're not constrained by server-side costs. Yeah, I would say.
Yeah, I totally, I hear you on that, and I if you want to go deeper into this one, man, I mean, I would say this starts off with being a recruitment problem, and I think recruiters have really ruined the industry in terms of creating the situation that you just described, because because I mean, the way jobs have been advertised. Well, sorry, 2 things have. If you want to get me started on this, 2 things. One.
Okay, let's get started. Yeah.
Okay. Yeah. So first thing is that we have a lot of kind of colleges, these courses popping up, which go and they teach a particular framework. they go and they will teach you Angular. Oh, well, who learns Angular? I mean, they'll go React, right? They'll go, I'm going to learn React. And somebody else will go, oh, I'm going to learn Node. And they come up with a certificate or some sort of skill in a very particular subset of what it takes to develop an application. Recruiters take that and now start exposing or start putting talent out there into the market based on these specific skills. And companies also are now picking between this menu of like Node, Angular, Java, right? Instead of hiring general engineers. And I think that there's a supply problem and there's a demand problem. The supply problem is that the schools are producing developers with very specific skill sets. And the demand problem is companies who don't know any better are looking at the supply and go, that's all that's available to me. And then they structure their organizations or their teams based on how talent is being thrown at you. That's kind of like my 2,000-foot view of the problem that you described.
And what's the second? You said the second. There's two parts to this.
One is people producing very specific skill sets, and the other is recruiters taking those skill sets and creating job profiles for it. When really a job profile should have at least 2 or 3 of those things.
Right. Yeah, I don't know. Actually, I don't know if I can comment or provide any insight on that. Where like, I don't know if recruiters are really deciding the architecture. Maybe it's the counter is like, I don't know if recruiters are deciding the architecture. It's still,
yes,
or the school at some point. I think it's like, but I think maybe the other thing is like, maybe us as I think maybe I said this to you before. Like us as engineers feel like we're like, you know, discovering, you know, knowledge and truth on the internet, but especially over the last 5 years, it's just become, you know, marketing dumpster fire. So anything you read, even as an engineer, you're probably being sold on something, and I think that's, to me, what I felt like happened with the current architecture is that, you know, there's people made a lot of money off of microservices and client-side rendering, and we got marketed to whether or not it was actually, and maybe it's also just a, you know, like a pendulum swing. Like I was going to also say that, like, if you really want to go back to it, you know, like even, you know, inventing, like all these things have, you can go back to like mainframes and being like, you know, like, okay, you know, all these things like, you know, job schedulers and event processors and queues and that sort of stuff, like those things exist on the mainframe and in some capacity or so, you know, everybody gets excited about, you know, like the latest, like, oh man, like this, you know, like Kafka or event-based architecture. And I'm like, all right, cool. It feels like, you know, no, maybe it's not actually that new. It's like some pattern from the recycled pattern from the 70s or 80s or something like this, or, you know, or same with NoSQL, right? Like, you know, there was NoSQL data, you know, there are other data stores than besides SQL back in the day too. Anyway, so that's another thought.
Yeah, I feel like I think we both agree that the situation that we started this with the situation you described, where it takes like 18 people to get like one thing done, and digging into why that is the case, I don't think it's a simple answer. And, you know, I gave like two reasons why. I don't think that's accurate. Actually, it's part of the problem, but I don't think we can pin down exactly what it is. But I think over time it's snowballed into where the complexity is not necessarily in the complexity of the change. It's the complexity of the people that need to coordinate to make that change. And yeah, unfortunately, that's where it has been. I mean, despite of all our great tooling, you know, all these freaking cloud, AWS, all this stuff that's happening, we certainly have gotten sexier technologies, but very poor processes to stitch those technologies together. And I think I think it's time for Agile Manifesto 2.0.
I go back to like in the 90s or whatever, late 90s, when the first websites, secured websites were coming out. I suspect those engineers were pushing out changes, pretty quickly, and before like the institutions started layering in like process on this, like the first engineers building, this early web, and they were building on like even more primitive versions of these like sort of monolithic architectures, and so I suspect maybe my float out for idea is that the reason we ended up partly here is it was not the technology, but the organization and process that eventually got implemented, and microservices is sort of like a reaction to that, especially if in a heavily siloed organization. You get this like little boost of velocity over in my area because I feel like I can ignore the other part of the org.
And I think that's the false promise of microservices, is that you can work in isolation. Is that you can own a couple of services and you can get really fast and deliver quickly because you have created this boundary, when in reality that boundary does not exist.
Yes.
In any sort of even medium to high complexity, even medium complexity application, your isolation boundaries, they're just not going to be there. I mean, there's going to be too much going on between things for you to sort of isolate and work in your own silo. I think I gave the example of the image service earlier, but that's a simple thing, right? I mean, for anything more complicated, you end up getting into orchestration there.
So we say is the conclusion, embrace the monolith? Is that our new?
I think I know. I mean, we're already embracing the mono repo.
Yeah.
The mono. I love the mono repo idea. I'm glad it returned with a bang. It's taken over. In fact, one of the poor decisions that I have.
No, go ahead. Sorry, I didn't cut you off.
I said one of the poor decisions that I have made in this current app that I'm designing is that I put the Node app in a different repo than the Next.js app. And guess what? I'm copy pasting. I got little models from Node to Next.js, and I got to fix that at some point. So I'm feeling that right now.
I was going to ask two things on that. So I'm with you on that one. Like, it goes back to like, Git is a great tool it was designed for like, massive, collaboration. And so it sort of became absurd that we like layered on micro repos as this like other thing we needed. And all it does is, like if you think about that too, or like a shared library is like a perfect example where like, okay, I go make a change in a shared library. I like have to go through this like compile loop to get a new version. And then then I go to another repo just to like increment the version. And it also like disconnects the testing. Like how do you test that shared library? Well, it's actually, you really need to test the application that you're about to throw out. So,
I mean,
so if the code was just in the application in the first place, like you'll be better tested and you'll have fewer like mechanical like nonsense changes of like version bumps that you don't have to do.
Yeah, totally. I think we've all, I think you've seen them. I've definitely seen them. I'm sure the listeners have seen situations where shared libraries just result in a ton of bugs just because there are more than one client for that shared library. And especially in Java, when you're now you can always like float versions and do semantic versioning and that kind of stuff, but nobody's good at that. I haven't met a single person who's actually good at floating versions properly. Like, I know the open source community is quite good at it or tries to be good at it, but within an organization, have I seen semantic versioning done ever right? Few and far between, man. Few and far between. I think we can move on. You wanna?
Yeah, sure.
Okay. Let's cover a couple of points. I know we briefly touched on functional programming, making me write more tests. I think it's sort of obvious why that is the case. I think the fact that you end up with pure functions just give you the ability to test them better because you don't have to worry about, I talked about setup costs earlier.
Side effects.
Side effects, yeah.
Yeah.
And one library that I absolutely love in Elixir is called Patch. It's a testing library, and it has the ability to mock out private functions, which again, I was taught if you went to school.
I want that.
You know what I mean?
Yeah.
It mocks out private functions, and the design pattern that I've been using lately to write better code, or is that you have a class or a module with a bunch of functions in it, and all your data access, the stuff that talks to the database, is in a private function. And then when you are testing that module, you mock out the private functions to return what the database would return. And I love the fact that as part of the Elixir guidance or the patch guidance, they said the example on the website is that, hey, if you want to write testable code, we don't want to get into the database and start firing up databases, just mock out the private function. And oh my God, it's almost like somebody gave me permission to be, Zerar, it's okay to do that. Go ahead. You can mock a private function. Nobody's going to yell at you. And as soon as I kind of did that, I'm like, oh my God, it's so easy to write testable code.
Yes. Yeah, I feel like there's I'm working in Kotlin mainly right now, and the database layer is Hibernate still. And maybe there's another way to achieve something similar, or at least I've been trying to experiment with this for Kotlin. And maybe this also leans a bit into Hibernate too. Is that the Hibernate objects are just essentially, I guess, POJOs, but maybe POCOs in the Kotlin world, plain old Kotlin objects. I mean, they have annotations, and you have to be sort of semi-aware of like what these annotations are doing. But what I've been trying to do is, I think a common pattern I've seen with especially Spring Boot apps is the service layer gets sort of fat, and it does a lot of things where the construction of the object, the database read and write, the querying, getting the object, all happens sort of in the service layer. So it becomes very hard to test. And what I've been trying to do is pull out the basically like the construction of the object graph. And like I call them like mutators and creators. I sort of stole them from Meta, which they have like a mutators and that sort of thing. But the idea is that separate your load of your entities or whatever you need. If it's a private function, great. You don't need a private function. But then with these entities, pass them, like if you're, let's say you're doing, like maybe in your case, you're even doing something like building a cart or something like this. But you want this to be a persistent cart or whatever that they can come back to or whatever. You load the cart and the objects in this sort of like span of this transaction. And now all you want to do is add another object to it. So you've loaded these objects, you pass them to the mutator. The mutator takes these objects, mutates them to the next state, which is a cart with now two objects or something like this. And then it just returns the cart, this object graph. And then you pass, the second part of persisting this back to the database, you persist it there. And then basically now your object graph is all in memory. There's the transformation to go from one state to the next. And so you can actually, again, you're in the world of like pure functions, writing testable code where your inputs are well known. And I've also like another great one I found is for, especially for like time calculation and that sort of stuff. Like you can just any, like, if you have a timestamp where people add this to cart, or some complex calculation, you can, again, like, if you put this as a pure function, either hanging off your mutator as like part of the mutation, like this, this rule transformation, you can just basically write a shit ton of test cases for this thing, because you've separated out, like, you don't need the database loads, you don't need the writes. Anyway, okay, I'll pause there.
No, I think you've shared the repo with me, so maybe you can send it to me and I can post it as part of the show notes. Yes,
it's very rough. Yeah, so
but the idea is the same. The idea is to somehow to basically have your test code pass in real objects to your business logic, instead of you trying to mock things or spy on things and so on. And one of the things I love about Elixir, and I know, is that, in Mockito or in Java, if you're there's one of the biggest smells that I see in Java code is the use of any when you are trying to say kind of assert what a function should take in your test code. Mockito.any string, any int, whatever, right? It's impossible to do that in Elixir. It's going to force you to, because it does pattern matching on the arguments. Okay. So it's going to force you to say, like, hey, I want this exact value. If you want to verify this function was called, you got to pass in the exact value that this function needs to take for me to verify it. So I think we're both saying sort of, you're talking in the Kotlin Java world where you, I think, have to construct a mechanism to do what comes for free for me in Elixir.
Quite possibly. It'd be good to know if there's other people ideas on how to do that in the sort of Kotlin world. And maybe like the last thing I'll say on this was that the real power, I think, comes in, like, going back to, like, you have like these complex rules eventually for constructing objects, and your objects can become quite large. If you've done this right, your test code, basically, if you need to construct a state, is like you use the same production code to construct the objects, to like mutate them to whatever state you want in your test, and then you can do assertions. And I think that's the other sort of huge benefit is, basically no mocks, which is, I think, a big win, because basically, like, mocks end up being fragile at some point. Like, I've been in cases where you want to like change some object, and now it's like mocked in like 50 different places, and you're just like, well, I don't know, good luck figuring out what the, what each of the, like, why was this person constructing it this way? Like, and then you have to go through 50 different tests, just to.
Totally. And the other thing problem with, again, this is not specific to mocks, but I guess it is for mocks, is that you sometimes in your test code want to test a particular case or rule, but your mock ends up being much bigger than what your test code needs it to be. So even though you have mocked something, like say you have a person object, the mock has like name, SIN card, whatever, SIN number, last name, date of birth. But all you're trying to assert in your test code is, does the name convert to uppercase properly, right? But your mock has like 18 things which you don't really care about, but it's still part. I mean, I know you're not using those 18 fields in your test code, but they're still there. And that always felt dirty to me, because it sort of breaks the sort of Kent Beck's rule of like minimum elements, right? Only work with the minimum elements. Here I'm working with 14 elements I don't need, but 4 I need. So, and there's no way for anybody to know whether I'm using those 18 or not. So in the creation mutation stuff that you're talking about, in the past stuff that I'm talking about, you really get to construct a real object specific to your test case, rather than a large object of which only portions you're using.
I think that's key too. Yeah, like you go write a mock, and you have like one a bunch of these when clauses to return all these special values. and then the developer passes this mock to your code that you're testing, and so it's doubly worse. You have this in 50 spots where you're mocking parts of functionality, or constructing these objects in certain ways that are probably not even valid in production, where like maybe in production it's impossible to not have a first name, but like you're testing the last name or something, so you don't even set the first name.
Yeah.
But like as an example, and then you pass it to some function, and now you have to go figure out, well, like which fields does my function like to go change this in the future when you change the code. It's just impossible at that point. So I've been
At that point you're trying to set off, trying to deal with a time bomb. At this point you have no idea the impact of your change, and
so you write an integration test.
Yeah, I think that's the lesson learned here, is that, and you touched on it earlier, is that sometimes you talk about changeability of your application. Back to the interview question, as long as it's changeable. And I feel like you should also be able to change your test code as easily as you change your production code. I know easier said than done, but I feel these are a couple of rules or a couple of kind of principles you can follow to make sure your test code is also easy to change. Hey,
it's sort of non-obvious. Yeah, like maybe the last. Yeah, I know you're sort of non-obvious. Like what is easily changeable test code, and that's that's like probably the challenge. And my thoughts there is the less test code you have, the better. So the goal should be to how much test code should actually be production code. And if you're writing mocks, you're probably writing code that ought to have been like a mechanism in your production system.
Totally. And this goes back to I feel like if you take an economic aspect to it, and you look at your test code as fixed cost and variable cost, and how much do you need to spend, how much fixed amount of money or time you need to spend to create your test. So that involves like setting up your service class so that it has all the right things in the constructor, making sure your fixtures are set up properly, just to even get one test working, versus how long does it take to add one incremental test to your suite. And you try to look at your test costs into those two terms. I think we have sort of come to we've sort of accepted the fact that our fixed cost is going to be high. I feel like we just kind of resigned to it. Is that, hey, we got to set up all these mocks so I can test this class. And I think how I understand your creator mutator pattern, and what I like about Patch and Elixir, is that there's almost zero fixed cost. I can go right into testing the functional logic of the function I'm doing and not have to worry about storing payloads, doing all kinds of stuff. I can get right into the detail of actually testing the business logic. And I feel that's what I find great. That's what I think good test code should look like.
Yeah, and at some level, it's probably all like a form of functional, like basically trying to pull the side effects out of your business logic, and using the tools of like whatever language you have to make, basically if you can write your code as functional code, pure functional code, then it's easily testable.
Hey, we had one more topic. Sorry to
I
mean, we're at the hour mark. It's been going. We could talk forever, but let's just round off with one quick. Okay. And I'll give some context on this question, because Mike, the question was, whose job is it to write requirements, right? And for the last the last year, I'd say, I've written a lot of code, man. And I've been a solo developer on this project called Jump Comedy. It's getting, it's a pretty big app at this point. And I'm telling you, man, I have absolutely loved having no barrier between myself and the customer. It reminds me of the time that I started my career back in 2004 in a small company where I used to call up the other person on the line and go, hey, what do you want this thing to do? You know what I mean? Yeah. And I've really enjoyed it. I've really I forgot how good development felt when you cut all the fat and you just get to talk to the person whose problem you are solving. And like, I've loved it. So, and I've always believed it's the developer's job to tease out the requirements from the person who wants the problem solved. General question. I don't know what your thoughts are on this one. I know
maybe this is why I like writing, internal tools as well at company, because that feedback loop is so tight. You'll know pretty quickly if other people at the company get value, because there's generally no product owner for an internal tool. So you start with the problem like, oh, this is annoying, this is an annoying thing, and then you solve it, and you see if other people start using your tool, and if they do, you're like, oh man, that's cool. I actually did solve a problem for other people.
It's like a dopamine effect. You actually get a bit of a rush when you see your code being used and you observing it and you kind of getting feedback on it and you iterating it again. It's been wonderful. And I'd almost forgotten why I got into computer science or why I got into programming until the last year. So it's been good. So I've always been an advocate of developers working extremely closely with business people. And I think that's one of the fundamental Agile principles. I think it's like number one on the principle.
Do you say business people or sorry, I didn't mean to cut you off.
Customers.
Yeah.
That's our bank background coming into the, into the mix, into customers.
Yeah, developers should work with business people.
Tell me a little bit about, if you can only, to tell me how things kind of work at Meta when you try to, when you try to solve problems. Like, how does it work? Do you have a BAs, or like what's the setup like there a little bit?
There are product managers or product owners, and I think I guess they're called managers there. And I think they probably end up owning a reasonably large problem set that engineers often have to help. Like they at least from my experience, there is a lot of like interplay between the product manager and engineers on developing the product. And maybe it's just in my little area that happened, but I assume that's probably by design at Meta. And even the way you're evaluated as an engineer is somewhat related to that, which is, you're measured on impact. So if your product owner is proposing ideas that don't, and impact is moving a metric at Meta. Maybe without getting too much into how Meta evaluates engineers, so like that's a rough way to view it. So if your product owner is not helping you get impact, you probably don't want to be working with that person. And so the third part of that is like the experimental, setup and analysis, which is like it's certainly the most like extensive setup and like engineering effort. Like part of your job as an engineer is to make sure the experiment runs successfully and you can get, a good signal out of the experiment. So I think they're very, very much more, experimentalists in some ways, even the approach to product.
Yeah, and I think that's the main value of product management, is to come up with different experiments. And that's the part that I, as much as I'm talking about like enjoying working on a problem, I wish I had somebody who was thinking in terms of, okay, what experiments have we not run? Like the other day, I released this feature where, when you check in tickets at the door, you scan your thing. We have that feature. And I was wondering, like, how do I make this check-in? Because I actually went to a show and I saw people like use the check-in, and I'm like, this is good, but it's very like linear. Like there's a group of 4 people coming in and they scan 1 ticket, 2 ticket, 3 ticket, 4 ticket. Yeah. And each scan is like 15 seconds or 10 seconds. That's 40 seconds right there. But the person scanning the ticket sees all 4 people there. So I'm like, you know what? Let me just add a feature which says check in order, where you scan the first ticket and then a little extra button pops up which says, you want to check in the hold order? And boom, all 4 people are checked in. So you don't need to scan the other 3. And I just like tried this out. And I looked at the logs this morning, and it's like one of the most heavily used features there is. And then I'm thinking to myself, okay, that was just me like contemplating going to a show, and I got that one right. What are all the things that I haven't thought of? What are all the things that I am not asking the customers? What are all the experiments that I'm not trying? And that's where I think you need product management. But
I'll put it like the other use case that like I'm working at a bank, so there's regulatory requirements. Like me as an engineer, like do not know all the regulatory requirements. So I also rely on my product person to be the contact point for, in some ways figuring out with, whether it's risk or compliance or whatever, like what are the,
what if I'm just falling asleep listening to this?
Yeah. So figuring out that part, I think, is also maybe part of the role, but I think it's like the danger is like, because of like, there's an asymmetry there that, not necessarily bad acting, but then engineers just rely on like the product, like rely on that person to tell them what to do. Like it becomes like a reliance.
Yeah. It becomes a gate. It becomes it almost becomes like a responsibility boundary. Like you no longer take shared responsibility. You kind of offload the responsibility to the product manager, who at some point just blends into a project manager.
Right. Yes.
And I think that's the balance that is hard to get right.
I find especially like especially in junior devs too. Like had a situation where it's like, well, I had a junior dev recently just basically expressed that exact thing. Like I'm just doing what the product guy says. I'm like no, that's not how we're building product here, right? Like it's a collaboration, and it was even like the thing the product person asked for was like one of these like off the cuff like minor things, like I want action X to happen before action Y. And the engineers like literally like went to action Y and started trying to couple action X to it. And I was like, wait, hold up. Like these are 2 independent things. Action X runs on its own time schedule. Like, why the heck are we trying to couple all these things together? And the answer was, well, the product owner said we needed to. And then I asked the product owner, like, well, why did you say that? And it was, oh, well, that's just how it was working in my brain. And I'm like, and
classic.
Yeah. Like there's no reason, but developers just sort of have so easily fall into the trap of like, the product person dictates exactly how the product should work.
Yeah. Totally. I don't think I have anything more to add on that front. Product management is a tough job, but I think one thing that I have sort of I've concluded is that the number one thing required for a great product manager is an experimentation mindset, and something and constantly asking, what am I missing? What have I not tried? Is my existing product really the best product? Am I making too many? Are my assumptions hardened over time that I'm taking to be true what may not be true, just because that's how things are? And as soon as you sort of kind of end off discussions in your head or like conclude your thoughts by saying, "Oh, that's just how things are," I think that should be a trigger that you should be thinking differently. I don't know. I've never been a product manager, so I don't know. But that's what I think. That's what I would appreciate in a product manager. Ian, I think we've hit the hour and 15-minute mark. This has been the longest of our podcasts. And thanks for coming on, man. We definitely need to do this again and cover a bunch of other topics. So thanks for making time.
Thank you for having me.
Okay.
This is a blast.
Okay, man. We will talk soon enough. Listener,
right.
Follow us on LinkedIn or not. I don't care. I don't care if you follow me or follow the podcast. Do it. Don't do it. We'll still keep recording it.